So for number 18, we have the following. A 20g, remember g is a unit of acceleration equal to 9.81 meters per second squared. So 20g is 20 times that. Centrifuge at NASA's Ames Research Center in Mountain View, California, is a cylindrical tube 58 feet long with a radius of 29 feet, shown in the figure. If a rider sits in a chair at end of one arm, facing the center, how many revolutions per minute would be required to create a horizontal normal force equal in magnitude to 20 times the rider's weight? So what we've got basically is this. I'm going to make the rider's mass m because it's not given. Yes, you could pick your favorite mass and it would work out just fine as well. So the force that we need, the inward force, which is going to be the centripetal force, acting this way, is going to be 20 times the weight of the passenger. Well, this right here would be the force of gravity on our person. And so we need the normal force, in this case the centripetal force acting to the center, to be 20 times that. And you can multiply that out. I'm going to leave off units just for clarity. Yes, this would be newtons, but it'd be 196 times m, the mass of our rider, newtons. How do we go from that back to centripetal acceleration? Well, if you remember, centripetal force is just equal to the mass times the centripetal acceleration. In this case, we know the centripetal force is this number right here. We can plug that in, and most of you can see already what's going to happen. The mass of the rider is going to cancel out, and we're going to end up with just a centripetal acceleration of 196 meters per second squared. Again, forgive me, I'm leaving off units just for clarity. We'll add them at the end here. We're looking for revolutions per minute, which is sort of like an angular velocity. So out of all the equations, I'm going to use omega squared r for centripetal acceleration. Yes, I know there's other ones, but I think this one's going to make it easiest on us. And we know this, or one last thing here, we need to convert the 29 feet going from here to here into meters. And it's about 8.84 meters, so I can plug that in down here. Plugging in our numbers, we get the centripetal acceleration, 196, is equal to omega squared times the radius, 8.84. And solving for omega, we get that. You're like, oh great, we're done. Well, one last step. They want this in revolutions per minute. So we have to actually do a little conversions. Working backwards, in this case, 4.71 radians per second. I can cancel out the radians. We know that there's one revolution is equal to 2 pi radians. And 60 seconds is equal to 1 minute. Multiplying that out, you'll find the answer is 45 revolutions per minute is how fast, or the angular velocity in RPMs, we would need to get to 20 Gs. Yes, that is incredibly large, even for a passenger on their back. Hopefully this made sense. Lots of variables in this case, but kind of interesting. Good luck.